Welcome back. Today we're going to be using those properties of logarithms that we went over last week to solve logarithm equations. So let's first review those properties that we learned last week. So the first one we learned said if you have log base b of a plus log base b of c, that's equal to log base b of a times c. So when you add two logarithms with the same base, you can write them as a single logarithm using multiplication. The second rule we had is very similar to that one, but it involves subtraction and division. And that says if you have log base b of a minus log base b of c, that's equal to log base b of a divided by c. And then the final one we had was when you have a a number being multiplied by your log, and what you can do is you can rewrite that as just a logarithm, a single logarithm. You can make that number the exponent on what you're taking the log of. So c times log base b of a would equal log base b of a to the c power. And then we also had a rule a couple weeks ago that said if you have log base b of a is equal to log base b of c, then this is true. Then a would equal c. Basically, what happens here, if you get two logs and they're equal to each other, the logs cancel out and you just set a equal to c. So we're going to be using these four rules today, along with stuff that we've been using all year to solve equations. So let's look at this first one here. Our goal is to get these equations, get both sides, left and right side, as a single logarithm. Okay? Well, the left side looks like it's a single logarithm, but because of this 2 here, it's not. So we got to get rid of this 2. So we can use this rule right here. We can take that 2 and move it as the exponent. So I can rewrite this as log base 12 of x squared. Now if I look at the right-hand side, what are we doing here? We're adding two logs that have the same base. Well, we can use our first rule up here that says when you add two logarithms with the same base, you use multiplication. So we're just going to take 16 times 4, which is 64. So the right-hand side becomes log base 12 of 64. So now we can use this rule. We got log base 12 of x squared is equal to log base 12 of 64. So these will cancel each other out, and x squared would equal 64. And then we can take the square root of both sides. So x is equal to plus or minus 8. Now, what we're going to do is make sure the answers that we get as possible answers is that we can use them. Well, where's x located? Right here. What's true about that number? That number, according to the logarithm definition, has to be a positive number. So if you plug positive 8 in there, that works. If you plug negative 8 in there, it makes it a negative. So we can't use the negative solution. So the solution is just x equals 8. All right, so let's look at example 2. Example 2, we're going to do it the same way. We want to rewrite both sides as a single log. Well, what are we doing on these two? Subtracting. They both have base 7. There's not a number in front of either of the logs. So we can use this rule right here and rewrite this as log base 7 of 125 divided by y. And that's equal to log base 7, which is 5. So now we can use this rule and mark out the log base 7s. So we got 125 over y is equal to 5. And then what I'm going to do is I'm just going to turn that 5 into a fraction so I have a proportion. Put it over 1. So now we can cross multiply and set them equal to each other. So 1 times 125 is 125. Y times 5 is 5y. So all we gotta do is solve this equation. 125 is equal to 5y. Take 125 divided by 5. So let's divide both sides by 5. We get y is equal to 25. And then let's make sure 25, we can use that. So if we plug it back in for y, here's the y. If I plug 25 in there, that number needs to be a positive number. 25 is a positive number, so it works. So y equals 25 is the solution that we're going to use. All right, I'm going to do 2 more examples with you. You'll see each types of these examples on your assignment today. All right, so let's look at example 3. Well, if you notice, the left side is already a single log, so we're good there. I'm just going to rewrite this as log base 5 of x. But we got to combine these together. But as they are currently written, we cannot combine them together because of the 1/2 and the 1/3. So we got to get rid of the 1/2 and the 1/3 first. So we can do that by using that third rule. We can move 1/2 to the fraction, the exponent of 64. And we can do the same with the 1/3. So we can rewrite this as log base 5 of 27 to the 1/3 power. Now, remember when you have a rational exponent, that means you're taking a radical. So this is the square root of 64 to the first. This one would be the cube root of 27 to the first. So we got log base 5 of x is equal to log base 5 of the square root of 64. The square root of 64 is 8. Plus log base 5 of the cube root of 27. Cube root of 27 is 3. So now we can combine these together to make it log base 5 of 24 is equal to log base 5 of x. Log base 5's cancel out, and x is equal to 24. And then if you check it, we can use it. So the solution is x equals 24. So make sure when you're doing today's assignment, make sure you're not skipping any steps. I want to see all the steps showing. I will take points off if you leave some steps off. All right, so let's do this last one. We're going to start it off the same way. We're going to try to rewrite both sides as a single logarithm. Well, these two logarithms both have base 5. We're adding them together. So we can write it as one logarithm with multiplication. So I'm going to take 3 times this quantity. So I'm going to take 3 times the 2x to get 6x. And I also got to take the 3 times the 1 to get 3. And that's going to be equal to log base 5 of 27. So now, log base 5 and log base 5 cancels out. We got 6x plus 3 is equal to 27. Subtract 3, subtract 3. 6x is equal to 24. Divided by 6, divided by 6, x is equal to 4. Make sure when you plug 4 back in here, 2 times 4 plus 1, make sure that's a positive number. If it's not a positive number, we can't use x equals 4. And then the solution would be no solution. But that is equal to 9. 9 is a positive number, so the solution is x equals 4. So again, make sure you're showing all the steps to receive full credit.